Hello students, I am Dr. Sanjay Punia. In computer arithmetic, we discuss about number systems and binary number systems till now. We discuss that how we can represent binary number systems in signed and unsigned form. When we have to represent binary number system in signed form, then there are three methods to represent them. One is sign magnitude form, second is ones complement form, and third one is twos complement form. Twos complement form. We saw over here that when we have to deal with sign magnitude form, then first bit of the number, that is most significant bit. This first bit from the left is called MSB, that is most significant bit, and this bit represents the number that the number is positive or negative. When a 1 is present in this bit, it means it is a negative number, and when it contains 0, it means it's a positive number. The rest of the bits are contains the magnitude of the number, the magnitude of the number. In ones complement, suppose I have to write the ones complement of plus 5, or we can say simply 5, or I have to write minus 5 in ones complement, then in that case, first we have to write the binary equivalent of 5, not 1 minus 5. That is binary equivalent of 5, and that is 101. After writing the original value, that is plus value of the number, we have to replace every 1 into 0 and 0 into 1. So this is instead of 1, this is 0. Instead of 0, this is 1. And instead of 1, this is 0. So this is the representation in ones complement. There are a problem associated with both of these, that is sign magnitude and ones complement, and that is that there are two different representations of plus 0 and minus 0. So this is the ambiguity in signed and ones complement. This is the reason that twos complement came into existence. To find twos complement, let us take an example. The same example. For an example, I have to find twos complement of 5. Then first of all, I have to write the binary equivalent of plus 5, and that is equals to 101. We know it. Then first we have to write the ones complement, and to find the ones complement, we have to replace 1 into 0 and 0 into 0 by 1. So this is 1, and instead of 1, this is 0. So this is ones complement we discuss here also. So these two are same, you can see from here. Then next step is to add 1 in this. So this is 1 1 0. 110. So the 2's complement of 101 is 011. So in this, the problem of ambiguity resolved means there is only and only one representation of minus 0 and plus 0, and that is equals to 0, 0, 0, 0, 0, 0, and 0. So this is the reason that we have to use the 2's complement when we have to perform any operation inside the computer. So we discuss over here that what's the need of number system. After this, we discuss binary number systems. We studied the representations of binary number systems. In today's class, we will discuss about the addition and subtractions in binary number system. That is first two operations of computer arithmetic. So let's start from computer arithmetic first two operation, that is addition and subtraction. Or let me bring the slide over there. This was the thing we done in starting. We did the number systems, different number systems. As I told you, we discussed this also. Total combinations of the bit. This is the signed representation, that is MSB represent the positive or negative value. Then to find the ones complement and two's complement, we completed till here in the last lecture. From today, we will start the computer arithmetic and addition and subtractions. So let's start from here. As we know that the arithmetic and logic unit operates on the binary number. So this is ALU, as we saw in the very first diagram of central processing unit CPU. There are two main parts, that is control unit and arithmetic logic unit, and this is the integral part to perform any operations inside the computer, like addition, subtraction, multiplication, and division. Here, binary additions and subtractions are same as we did in the decimal. So, the presentations of decimal will be reflected in the case of binary addition and subtraction. Let's try to understand it from here. If we have two numbers A and B, first of all, we will try to understand the concept behind addition and subtraction. If we have two numbers A and B, then as I discussed earlier that total possible combinations are 2 raised to the power n, and n are total number of inputs. Over here n is 2, so 2 raised to the power 2 is equals to 4. So there are total 4 possible combinations, that is 0, 0, 0, 1, 1, 0, 1, 0, and 1, 1. So these are 4 possible different combinations when we have two inputs A and B. So when we have to perform addition on these two numbers. This is a number A, this is a number B. Here can be 0, 0. So in first case, when we have to add 0 and 0, then addition of 0 and 0 is 0. So you can see from here that addition of 0 and 0 is 0. It is represented by sum, that is S over here, and there is no carry. As we perform these additions in the decimal, so we can reflect it, we can compare this addition from the decimal numbers also. So there is no carry in this case. Now suppose the inputs are A and B. The value of A is from here. The value of A is 0. The value of B is 1. From here we can see the value of B is 1. Then sum of these two numbers, that is 0 and 1, will be 1. And there will be no carry. That is, there will be no carry. When we will perform 1 and 0, the value of A is 1 and value of B is 0, means this combination, then it is again 1 plus 0, that is 1, and there is no carry over here. The concept of addition changed in binary number over here, that we get a carry when we add 1 plus 1. When A is equals to 1, and B also equals to 1, this is the fourth case, that is this one, that is this case, 1 and 1. When we are adding A plus B, then 1 plus 1 is 2. 1 plus 1 is 2, as we do the addition in decimal numbers. So 1 plus 1 is equals to 2 in decimal, and 2 in binary is going to be represented by 1 and 0. 1 and 0. So from here you can see that 1 and 1, the sum is 0, and this 1 is a carry. This 1 is a carry. So in the simple words, we can say that suppose we have a number 0, 1, 0, 1, and another number is 0, 1, 1, 0, and I want to add these two numbers, then we have to start from right as we do in decimal numbers. So this is 1 plus 0. This is third case, that is 1 plus 0 is sum is 1 and carry is 0. So there is no carry. So carry is 0. When we are adding 0 and 1, that is second case, then sum is 1 and carry is 0. There is no carry. When we are adding 1 and 1, means this is the fourth case, and we are getting sum is 0 and carry is 1. So here sum is 0 and carry we have to add in next bit. So we have to add 1 over here. So 1 plus 0 is equals to 1. So this is the summation of these two numbers. If I want to represent this number in binary, in decimal from binary, then this is equivalent to 5 and this is equivalent to 6. Then 6 plus 5 equals to 11. And when I will convert this 11 from decimal to binary, then this is equals to 1011. So when we have to perform the addition in binary numbers, then that is same like decimal numbers. And we saw that when both the numbers are 1, in that case we get a carry, otherwise there is no carry at all. So this was the case when we have to perform the addition arithmetic operation. Now we will see the arithmetic in case of subtraction. So in subtraction, suppose there are also two inputs as we discussed in addition, input A and input B. This is the value of subtraction, and we know as in decimal numbers that if we are not able to subtract 1 from the above number, then we have to take a carry from the next bit. If I have 1 and I have these two numbers, 1 to subtract these two numbers, then I will get a 0. We will see over here just now. So when we will see the first case, means value of A is 0, value of B is 0, and we have to subtract this, then the subtraction is 0 and we are not taking a carry. So subtraction, the value of subtraction is 0 and we are not taking a carry. When we will discuss this case after these two. So let us try to understand these two first. So when we have to perform A minus B and A is 1 over here, B is 0 over here, when we have to perform the subtraction of these two, so this is 1 minus 0 is 1, as we know in the case of decimal also. So this is subtraction is 1 and we are not taking any carry at all. In the last case, when we have to perform 1 minus 1, means the value of A is 1, value of B is also 1, then in that case the subtraction is 0 and we are not taking any borrow also. So this was the case in these three. Now we will try to understand the fourth case when we have to subtract 1 from 0. 1 from 0 means the value of A is 0 and value of B is 1. So as the case in decimal, when we have to perform these type of operation in subtraction, then this number is smaller than this. Hence, we cannot perform the subtraction. In this case, we have to take a borrow from the next bit. So when we are taking a borrow from the next bit, in that case, it becomes 1. After taking a borrow from the next bit, instead of 0, it becomes 1. So this is 1 minus 1 is 0, but we take a borrow. So you can understand it from here that in this case, when the input A is 0 and b is 1 means when we have to subtract 1 from 0, then the subtraction value is 0 as we discussed over here, and we are taking a borrow from the next bit. So this happens in case of subtraction. Over here, we are trying to understand the operation of addition and subtraction in case of binary. We discussed these two at the time when we studied the adders and subtractor also. So this was the thing that we revised over here. We are not making any circuit with respect to adder or subtractor over here, because we have to see that how the operations are going to be performed. So this is the case of computer arithmetic multiplication, and this is about the division. So let's see this two also, that when we have to perform the multiplication of two numbers, those are 0 and 0 in binary, then the value of multiplication is also 0. As we know that in case of decimal, suppose I have to multiply 3 with 0, then the result is also 0. Same over here, when any of the bit is 0, then we are getting result as a 0. Over here, input A is 0, input B is 0, so we are getting a 0. When any of the one input, in this case A is 0, in this case B is 0, so we are also getting 0 as the multiplication of these two. In third case, the value of A is 0, the value of B is 1. Here also one value, one input is 0, so we are getting the multiplication 0. Only and only there is one case when both the inputs are 1, then we get a 1 at the output. It means it works as a AND gate. It works as a AND gate. Means when there are two inputs A and B, then output is A dot B. Means there will be the value at the output will be 1 when the value of A is 1 and value of B is 1. Otherwise, in all the cases, it will be 0. So, if there are two inputs A and B, then output is only 1. Only and only 1. In the last slide, if you will see, in case of addition and subtraction, the results has two values. One is for sum and another is for carry in case of addition, and in case of subtraction, one is for subtraction, that is A minus B, and second one is for borrow. But in case of multiplication, we have only one output, and that is either 0 or 1. And the value of output is 0 when any of one input is 0. In case of division, or in case of division, there are four things. There are four things when we have to divide a number, as we know in the decimal also. Suppose I have to divide 5 by 3. 5 by 3. then in that case, this 5 is called divisor, this 3 is called, sorry, this 5 is called dividend, this 3 is called divisor, and when we will, these two are inputs, these two are inputs. There are two inputs A and B, where A is dividend, this is A in this case, in this case 5 is A, and divisor, that is B. So this is B. So when we will perform this operation in binary, then suppose I have to divide 5 by 2, then this is 2 2 4, and remainder is 5 minus 1, that is 1. So in the output we get two values, one is remainder and second is quotient. So this is quotient and this is remainder. As we know, in the case of division, the value of quotient is not defined everywhere. At some points it's undefined, and when this is going to divide by 0 means when we divide any number, suppose n is a number and we are going to divide this number by 0, then in that case this is not defined. So over here you can see this is A and this is B. We are performing A divided by B. So in second case, we will discuss first and third case after second and fourth. We will discuss these two cases after this one, second one and fourth one. So when we are dividing 0 by 1, in that case the value is 0. When we are dividing 1 by 1, in that case value of this is 1. So these two are clear, but when we are going to divide any number by 0, as you can see in first and third, over here the value of B is 0. It means we are going to divide a number by 0. The number can be, as the value of A can be 0 or the value of A can be 1. So possible combinations are 0 divided by 0 and 1 divided by 0. And as I told you that when any number is going to divide by 0, then it is not defined or it is undefined. So result is not defined always, as we discussed in these two situations. So this was about the arithmetic operations, that how the different arithmetic operations are going to perform in ALU. In next class, we will discuss that how we can perform these operations on the number. We will take example to understand this over here in computer arithmetic, and we will understand the overflow also, that what is overflow and how we can detect that. So in today's lecture we discuss about the rules of arithmetic operations, Those are addition, subtraction, multiplication, and division. In case of addition and subtraction, there are two outputs, sum and carry. In case of subtraction, there are two outputs, subtraction and borrows. In multiplication, there is only one output, and the output is 0 when any of the input is 0. In case of division, when a number is going to divide by 0, in that case it is the result is not defined, means undefined. So thank you, thanks a lot. In next lecture, we will discuss about the operations on computer arithmetic. Thank you.